We throw around the term software engineering all the time, as if it's this solid, well-defined thing. But what if I told you that from the very beginning, that phrase was designed to start a fight? This is the story of a field that, for decades, has been struggling with a really basic question: what is it exactly?
Okay, let's get right into it. It all starts way back in 1968 at this conference sponsored by NATO. And the organizers, they didn't pick the name software engineering because it was accurate. Nope, they picked it because it was provocative. It was a challenge, basically thrown down at a pretty chaotic and disorganized industry.
So why was this simple phrase so charged? What was so controversial? Let's dig into the dream of software engineering versus the reality of what was actually happening at the time.
You look at a formal definition, like this one from 1990, and it all sounds so reasonable, right? A systematic, disciplined, quantifiable approach. It gives you this feeling of order, of control. But that neat and tidy description completely papers over the messy, chaotic reality of how this all started.
See, here's the thing you have to get. The term wasn't a description, it was an aspiration. By calling it engineering, the organizers were basically saying that whatever people were doing to build software back then was the opposite of engineering. It was a critique, a call for software development to grow up and get serious, like civil or electrical engineering.
So what was the big problem that needed such a dramatic solution? Well, it was something they were calling the software crisis. And this is where things get really interesting. When experts got together years later to talk about the history of it all, it turned out nobody could agree on what this crisis actually was, or even if it was a real thing at all. Was it a genuine industry-wide failure, or was it something else entirely?
The wild part is, everyone had a different theory. Was it a technical problem? Hardware was just getting way too fast for our software techniques to keep up? Or was it a problem of expectations, with everyone suddenly demanding these incredibly complex systems? Or, hey, maybe it was just a few big, splashy failures that got everyone panicking. Some people even thought it was just a narrative, an attempt by developers to make their craft seem more professional. Or maybe it was customers trying to get a handle on costs and deadlines. There was just no single answer.
All right, so the big idea was to make software more like traditional engineering. But does that comparison really work?
Well, the folks who loved this analogy, they pointed to history. They'd say, hey, look at other fields. Think about it. Collapsing bridges, the Swedish warship Wasa that literally sank right after it was launched. Their argument was that these other disciplines learned from their disasters. They developed math and rigor, and that's exactly what software was missing.
And when you put them side by side, the gap was just massive. Traditional engineering had the laws of physics on its side. They could use predictive models to calculate if something was going to work before they even started building. Software? Not so much. It was mostly trial and error. One writer even called it a pre-engineering phase. You had these vague, constantly changing interfaces and almost no shared foundations. It was a totally different world.
So the message was pretty clear, right? For software to mature, people had to stop reinventing the wheel. They had to learn from how other engineering fields grew up, find their own scientific footing, and start building on that.
Which brings us to 1996. A group of computer scientists decided, okay, let's do this. They got together with a bunch of historians asking for that historical roadmap. But the answer they got was not at all what they were expecting. See, the computer scientists walked in wanting a recipe. They were looking for a set of rules they could just lift from the history of civil engineering and apply to software. And the historians basically had to tell them, yeah, that's just not how history works. You can't just copy the developmental path of one field and paste it onto another to fix your problems or figure out who you are.
And that disconnect, it revealed that this whole software crisis thing was just the tip of the iceberg. The problems you could see, the late projects, the buggy code, they were just symptoms of a much deeper, more existential problem.
And that led to the real bombshell. The conclusion was, after decades of arguing about it, the field wasn't just in a crisis, it had an identity crisis. It was a discipline that was still fundamentally unsure of what it was supposed to be. This identity crisis points to something missing at their very core of software development, something other engineering fields built over centuries and just take for granted.
To really drive this point home, one of the guys at the seminar, Jochen Ludovic, came up with this brilliant metaphor. He argued that a true engineering discipline is like a strong, stable arch. It's a whole culture, really, held up by all these different building blocks that have to lock together perfectly.
So what about software? Well, when you look at the arch, a lot of those key blocks were just missing. You don't have a long tradition of craftsmen and guilds to look back on. There are very few universally accepted standards. A shared, sound theory that everyone agrees on, it's still debated. Customers often can't tell good quality from bad, and the development cycles are anything but slow and steady. Without all those pieces holding it together, the arch is wobbly. The culture is incomplete.
So this brings us to today. Our entire world now runs on software. But the questions they were asking decades ago are still so relevant. Has software engineering finally built its cultural arch and found a stable identity? Or is this state of perpetual crisis, of constant reinvention, just the nature of a discipline that's fundamentally different from anything that came before it? It's a question worth thinking about.